It's chemistry and you are watching Chem Science.
Let's continue with our topic ionic equilibria. In our earlier video, we had learnt about indicators, various indicators, their color change, and how to choose an indicator for a particular reaction or titration. In this video, we'll learn about different titration curves, that is, strong acid versus strong base will have what type of curve and what indicator to choose for this type of titration, and similarly we'll go ahead with the strong acid versus weak base, a titration of a weak acid versus strong base, and also the titration of a weak acid versus weak base, and how to choose indicator for each and every type of titration. So if you have not seen our earlier video of indicators, you can go through the video to see what are the different indicators and how to choose an indicator. Also, you can see the description to find out a link to explore more resources on the site. For an acid-base titration, there is always a change in the pH if a base is added to the acid during titration or a vice versa process. But in most of the cases, the change in the pH is sharply for the several units at the equivalence point, and this allows us to detect the end point of the titration with the help of an indicator. Now, if you want to find out what's the difference between an equivalence point and an end point, still you can go ahead with the earlier video of indicators where we have explained the difference. Now, the actual change in the pH during the titration, that depends largely on the strength of the acid and base used. In the sense, acid is a strong or a weak, or if the base is also a strong or a weak, that decides the change in the pH during the titration. Now, that can be detected by plotting the graph of the change in the pH with the addition of the titrating solution. So suppose if we have taken an acid in the conical flask and we are adding a base to the acid, then we can plot a graph for the change in the pH, and such different curves will be obtained for the combinations of weak or strong acids with the weak or strong bases. Now, such different curves, what are these different curves, that we will see in this video. So let's start with our first titration of a strong acid with the strong base. Now, in this titration, we have taken 50 centimeter cube sample of 0.1 mole per dm cube concentration of a strong acid like HCl, and we are adding gradually a strong base of the concentration of 0.1 mole per dm cube NaOH. Now, as NaOH is a strong base and the acid taken HCl is also a strong acid, we will see what is the curve produced during the titration, that is the pH curve. So let's see what is the pH curve produced during the titration of a strong acid and a strong base. Now, as we have taken 0.1 mole per dm cube of acid and we are adding a base to it, so the starting pH will be the pH of the 0.1 mole per dm cube HCl acid. Now, if you know the method of calculating the pH, then we should know that the pH of a strong acid of 0.1 mole per dm cube acid should be 1. So here our curve will start at 1 pH. And if you want to check the calculations of the pH of strong acids, weak acids, strong base and a weak base, you can check our earlier video of the calculations of pH, pOH and pKw also. Now, we can see here that the HCl and NaOH used, if you write a reaction of HCl reacting with an NaOH to produce the salt NaCl and H2O, we can see that it's a balanced reaction. The stoichiometry is 1:1. So here, if we are using a 50 centimeter cube of acid of the same concentration as acid, then we can say that approximately 50 centimeter cube of base itself will be required for the endpoint. So now let's start plotting a graph of acid starting with the pH of 1. So the pH 1 curve will go almost horizontal till 50 centimeter cube of the base. Now when we are about to reach the 50 centimeter cube, the pH may start increasing a bit. At 50 centimeter cube, the pH will sharply increase. So our pH curve is going up sharply as the pH increases at the equivalence point, or you can say the end point. Now if the base used here is also a strong, the pH of this base should also be more than 12, approximately 13 or 14. So here the pH curve ends at about 13 to 14 pH units. So this is how the pH curve will be seen. From this curve, we can observe that the pH starts increasing just before the equivalence point, and till then the pH is almost the same, or you can say only there is a sharp small change in the small increase in the pH. Now here you can say that you can see here that the equivalence point has covered a pH of a wide range from approximately 12 pH units to 2 pH unit. So now let's talk about choosing an indicator for such an pH change or for such an titration. Now as we had seen earlier in our video of the indicators, that the different indicators have a different end point at various pH. So as we can see here that the phenolphthalein, bromothiamyl blue, litmus, methyl orange have their own end point of the change in the color, where they will show the change in the color. So here we have to choose an indicator whose indicator change in the color or the end point of the indicator lies in this vertical portion of the curve. Now here we can see that almost all the indicators have their endpoint. Their color change lies in this pH unit. So we can choose any indicator, but as we can see that the middle point of these equivalence point, the vertical line is approximately at 7. So it is advisable to choose either the indicator bromothiamyl blue or litmus, whose change in the pH color change endpoint lies in this area, that is the middle point of the vertical portion of the curve. So the suitable indicator for such a curve can be bromothiamyl blue or litmus. Either of the indicator can be chosen for the curve of or the titration of a strong acid and strong base. Now let's go ahead with the next titration of strong acid with the weak base. So here again we have chosen a strong acid HCl of the same concentration 0.1 mole per dm cube, 50 centimeter cube volume of the acid, but the base chosen is a weak base like ammonia, again of the same concentration 0.1 mole per dm cube. So let's draw a pH curve for such an titration. Here again you can see that we have taken a graph grid where pH is taken on the y-axis and the volume of ammonia or the base added in centimeter cube on the x-axis. And as again we know that the pH of 0.1 mole per dm cube strong acid should be 1 at the starting. So it goes ahead with a horizontal line, almost a horizontal line with only a slight increase in the pH till the equivalence point. So here we are drawing an almost the horizontal line. Then it increases slightly at approximately just above the equivalence point. So here comes an vertical line at 50 centimeter cube of the acid. So pH will sharply increase at 50 centimeter cube of the base added, but as the base added is a weak base. So the pH of a weak base, you can say that will be approximately 10 to 11, and you won't get an exact horizontal line. There will be a curve of such a weak base. So this is the pH curve you will get. Now here you can see that the vertical portion of this curve is having a pH range of about, you can say that 6.5 or 7 to 2, or you can say 3 here. So here are 2 to 3 pH units which are showing the vertical line in the pH curve, and so the equivalence point of this titration should also lie in this pH range, that is the pH of 3 to 7, you can say. I'm not able to draw the curve properly, but you can see that the horizontal line is there for the strong acid, but as the base was weak, there isn't a horizontal line, but it's a curve which is drawn here for the weak base. Now let's talk about the indicator which we are going to choose. Now here again we have a list of few indicators which have their endpoints at a particular pH, and as we have already seen that the indicator chosen should have its endpoint between the pH unit of 3 to 7. So if you talk about such an pH range which shows the color change, you can see here that bromothiamine blue is exactly showing at 7, litmus is showing at 6.5, which is very near to 7, and methyl orange is showing a pH range of 3.7. So here you can choose these two indicators, out of which you can choose any one to show the color change for this particular titration, because that lies in our vertical portion of the curve, 3 to 6.5 or 7. Bromothiamine blue is not suggested because it shows a pH unit color change at the pH of 7, which may not be proper. So if you choose an indicator between this pH unit, then we have choice of two indicators, that is litmus and methyl orange. So the indicator in the range of 3 to 6.5 or 7 can be either litmus or methyl orange. These are the two indicators you can say that are suitable for the titration of a strong acid with the weak base. Now let's see the titration of a weak acid with a strong base. Here we have taken a weak acid, ethanoic acid of again the concentration of 0.1 mole per dm cube with a 50 centimeter cube of volume, and it is titrated against a strong base of 0.1 mole per dm cube NaOH. NaOH, as you know, is a strong base. So let's draw a pH curve for the titration of a weak acid with a strong base. Now as we know that weak acid will have a pH range starting with 3 or 4. So let's start here with 3.5 approximately. You can calculate the pH of a ethanoic acid considering its Ka value and the concentration, and you can find out. But here we are taking it approximately. So approximately it should be between 3 to 4. I am taking it as a 3. So here, as it's a weak acid, we won't get a horizontal line. So it should be a curve which is rising gradually with the addition of the strong base. So it goes up at 50 centimeter cube. It increases sharply with a vertical line. Now as we know that the NaOH is a strong base, so it should have a pH of approximately 13 to 14. So I am drawing it the pH of a strong base at about 13 with almost a horizontal line, and then gets joined with the equivalence point. Not able to draw it properly. Now with this curve, we can see that the vertical portion of this curve is between 10 to 7. Now this portion is very small for a weak acid and a strong base. So equivalence point should lie between these pH range, that is from 7 to 10, or you can say 11. So again, if we choose an indicator with this pH range, so it should lie in this pH range from 7 to 10. So from 7 to 10 we have only one indicator of phenolphthalein with the pH of 9.1 to show the color change. So this way we can conclude that the suitable indicator for the range of 7 to 10 should be phenolphthalein, which shows the color change in this pH units of 7 to 10, and the color change for the different indicators you can go through again in our earlier video of indicators. So here the suitable indicator for the titration of a weak acid and a strong base should be the pH curve as shown here, and the indicator chosen is phenolphthalein. Now let's go ahead with our next titration of a weak acid and a weak base titration. So here we have taken a weak acid of 0.1 mole per dm cube concentration ethanoic acid and a weak base ammonia, again of the same concentration 0.1 mole per dm cube. And let's draw the pH curve for such an titration. And as we are starting with a weak acid, and we know that the starting pH of a weak acid is higher, that is approximately of 3 or 4. So let's draw a curve at 3 units, starting at the 3 unit, but it won't be a horizontal line, it's going to be a curve. Also it increases, keeps on increasing till the equivalence point, and we know that the base is also weak, so its pH change will be, the final pH will be approximately at 10, also with a curve. So I'm drawing a curve at approximately 10. Again, it's not a horizontal line, and the equivalence point, so you can make out that the equivalence point of such a titration lies in a very small pH range. So here is our curve for the titration of a weak acid and a weak base, and as it's a curve for both weak acid and a weak base, here we don't get a horizontal line at any particular pH. Both are the curve because of the weakness of the acid and base. So we can say that the vertical line of the pH curve is a very small. Now as it's very small, it's very difficult to choose an indicator which has a varying pH of 9.1 or 7, 6.5, 3.7. So here now the problem is that it's very crucial to choose an indicator which exactly shows a proper color change. So generally such indicators are not suitable for weak acid and weak base titration. So indicators are not used for such pH curves. So generally it's only the pH probe which is used to find the equivalence point, and indicators are not used for such titrations. So for indicators we can say that for such titration of weak acid and weak base there are no proper indicators, no suitable indicators. And as we have seen the different curves for the different types of titration of the varying concentrations of the acid and base, or you can say the strength of acid and base, a strong acid or a weak acid against a strong base or a weak base, all such titration shows different types of curves which we have seen here. And we have also seen here that what are the indicators which can be chosen for such curves according to its pH range of showing the color change. I hope the points are very clear, and if you have liked this video, do not forget to subscribe the channel.